morning, all of you. In today's session, we are going to discuss about the chemistry which is related with the international chemistry entrance and competitive examinations, national level JEE Advanced and JEE Mains, NEET chemistry entrance examination, Telangana and Andhra Pradesh EAMCET examination. For all the competitive exams, this kind of content will be very much helpful. And these are the questions which collected from the previous year question papers, and the detailed explanation will be provided to you. Hope this will be very much helpful for your further preparation, and you are aspiring for that will be definitely fulfilled. Let's enter into our first question. Here, ethanol can be made by the reaction of steam with ethene. This is the kind of synthesis of ethanol. Ethanol is the hydroxy compound, can be synthesized by multiple pathways. Among all, steam and ethene when combined so that ethanol formation. This is the simplest example of addition reaction. Unsaturated ethene can be treated with water. Steam is nothing but high temperature water is called a steam. So whenever water reacted with ethene, formation of ethanol is the addition reaction. Write the word equation for this reaction. We need to give its a word equation, means all the chemical components are mentioned in the word format, and followed by these questions to be answered. What conditions are needed for this reaction? Tick boxes. Enzyme catalyst is required for this. High temperature is required, like 300 degrees centigrade. Low temperature 10 degrees centigrade is required. Phosphoric acid is the catalyst, or presence of light is required. All to be answered for the synthesis of ethanol by using steam and ethene as a reactant. Let's go with one by one. Word equation. Right. So in order to get the word equation, ethene is the gas, right? So CH2 double bond CH2 can be added with the water, so that formation of ethanol. Along with this, delta H is equal to minus 45 kilojoules per mole, right? So heat liberated. Negative delta H is nothing but exothermic reaction. So this is the way we can mention, and this is called a chemical reaction. So if you want to write its word equation, so if you want to write its word equation, what we have to do? The thing is, here ethene, we have to write ethene plus steam. Here water can be mentioned with steam. Formation of ethanol, we can mention the name of this compound called ethanol, so that it will be entirely given in the word format. Ethene plus steam gives rise to ethanol is the word representation of this ethanol formation. And next, let's go with the what conditions are preferable. Enzyme catalyst. In order to synthesize this ethanol by means of this addition reaction, we have to go for the catalyst called phosphoric acid. So phosphoric acid is the mineral acid which can be used as a catalyst, so that enzyme catalyst can be omitted. High temperature 300. So if we observe this, one volume of ethene consumes 0.6 volumes of steam, so that 300 degrees centigrade temperature is required to be maintained. So 300 is the right answer, where we are heating the components at 300 extremely high temperature. So low temperature can be omitted. This is not the correct option. Phosphoric acid catalyst is the right answer. We can tick this one. Presence of light. If you observe this one, we are maintaining thermal conditions so that light can't be applied. So here the right answers will be high temperature, phosphoric acid catalyst, and only these two will comes in this synthesis of ethanol. In order to synthesize the ethanol, ethene treated with steam at 300 degrees centigrade temperature and 60 to 70 atmospheric pressure is applied, ethanol formation is possible, right? So phosphoric acid used as the catalyst in this reaction. So this is the way we can answer for question number 1. The word equation is given, and characteristic conditions required for the synthesis of ethanol by the addition reaction also mentioned. Let's go with the question number 2, where the diagram shows the apparatus used in the electrolysis of molten sodium bromide. This is the process called electrolysis, and molten sodium bromide means sodium bromide in aqueous condition. It was dissolved, it was melted at high temperature, molten condition, so that we can find a compound like sodium and sodium cation and bromide anion will be generated. So this diagram is given to you, and based on this diagram we have so many multiple questions over here. Let's solve one by one. What does the term electrolysis means? Electrolysis, here two words are there, one is electro, second is lysis. Electro means by the application of external electricity. Lysis means existing compound was broken. Lysis means breaking of existing bonds, right? So here, if you observe this one, definition of electrolysis, the chemical process in which bonded elements or compounds are dissociated by the passage of electrical current. If you take water, by electrolysis process, it will be dissociated into hydrogen and oxygen, elemental. What molecules will be generated? This is a process called dissociation of water by applying the electricity, so that hydrogen oxygen is called electrolysis, right? So here the typical electrolytic cell is provided over here. Cathode is made up of negative charge, anode is a positively charged one. Here this container is filled with electrolytic solution. External current circuit is required in order to supply the energy, and the diaphragm will be there in order to separate anode from cathode, right? So cathode anode compartments are provided. Cathode negatively charged, anode is a positively charged one. This is called electrolysis process. This is very well explained. What is electrolysis, right? Dissociation of any substance in the presence of electrical current is called electrolysis. Then RSTU, whatever symbols provided, we need to label them, right? So in the diagram, above represents the cathode. Which letter? RSTU. The diagram above represents the cathode. These many options are there. Where the cathode is located, that cathode should be labeled. Let's see. Here we are passing electrical current from this external circuit, so that here R denotes what? Applying the external current. Okay, one of the electrode is cathode, one of the electrode is anode. Just now we saw negatively charged electrode is called cathode, positively charged electrode is called anode. Negatively charged electrode is called the cathode. So that U is the electrode. U is the electrode which is called a cathode. So U is the right answer for this question. Let's label all the remaining also. S is the positively charged electrode. Positively charged electrode is called the anode. So S denotes the anodic electrode. U is the cathodic electrode, and T is the electrolyte here, in which solution two electrodes are dipped. That is called electrolytic solution. So the correct answer for question number A2 will be U. U is the cathodic compartment, cathodic electrode. Right. Let's move on to the next question. Complete the word equation for the electrolysis of molten sodium bromide. Sodium bromide upon melting, that will be converted into sodium bromide by the electrolysis. It is converted into sodium metal, and bromine gas will be generated by means of electrolysis process. Sodium will be deposited at cathode. Bromine gas is evolved at the anodic compartment. Right? The question is, complete the word equation electrolysis of molten sodium chloride. We did the electrolysis process here. If you observe, sodium got electrolyzed and the sodium cation will accept the electrons at cathode and will be converted into metallic sodium. Bromide ions will lose the electrons and converted into bromine metal and will escape at this compartment, anodic compartment, right? So here this is the word equation. Sodium bromide is called the ionic compound. By the process of electrolysis, metallic sodium and bromine gas will be generated. Metallic sodium at cathode, bromine at the anode. Cations at the cathode, anions at anode. Simply you can remember in electrolysis process. This B is also completed. And next question, a solution of sodium bromide in water is a neutral. Neutral means the pH must be 7, because in accordance with the pH scale, we can mention neutral. Which one of the following pH values are neutral? put a ring over the correct answer. You have to put a ring over the correct answer, right? So pH 7 is the correct answer for this that one, and this is the Sorensen pH scale where you can find. So here pH 7 is said to be neutral one, above that basic, below that acidic one. So here this pH 7 is the correct answer for the neutral compound, sodium bromide. So sodium bromide is the typical example for the salt which is made by the combination of strong base versus strong acid. That's why compound generated is exactly neutral. Hence we can put 7 is the correct answer. Okay. By this, all the questions whatever mentioned in this question number 2 got answered. Electrolysis and what is cathode and what equation and what will be the pH of neutral solution. So I hope this question is very clear. Let's move on to question number 3. Dissolving 1.24 grams of white phosphorus in boiling sodium hydroxide solution in an inert atmosphere gives a gas Q. Amount of copper sulfate required to completely consume the gas Q is, right? First of all, we have to identify what happens when allotropic white phosphorus, red phosphorus. So all these are the allotropes of phosphorus. When this white phosphorus reacted with the boiling sodium hydroxide, what could be the product? First, we have to identify. After getting that product, how it will be reacted with the copper sulfate. And then only we will go for amount of copper sulfate required for that one. The given data is atomic masses of hydrogen is 1, oxygen is 16, sodium is 23, phosphorus 31, sulfur 32, copper 63 are provided. For this question, after solving everything, you have to get 2.38 will be the answer. Let's move on. How can we solve this problem number 3? In order to get that one, first white phosphorus is taken. Phosphorus always valuable in the form of P4 tetrahedral geometry, all the corners occupied by the phosphorus atoms, and treated with the sodium hydroxide. Phosphorus, upon treating with sodium hydroxide, in the presence of water, the formation of pH 3 called phosphine and sodium phosphate are possible. Okay, so in this P4 called elemental phosphorus, this is the white phosphorus, can be treated with sodium hydroxide and water gives rise to pH 3 and sodium phosphate. When the released pH 3 can be treated with copper sulfate, copper phosphide, and sulfuric acid will be generated. Here we have to remember sodium hydroxide present in excess. We can take here 3 moles of 1 mole of phosphorus consuming 3 moles of sodium hydroxide. So that phosphine formed is 0.01 mole only, right? The amount of copper sulfate required can be taken as exponential 3. So here exponential 3 is given for copper sulfate. The 3 and 0.01 moles of pH 3 got reacted with copper sulfate, so that 0.01 moles will be taken and its exponent is 2. 3 into 0.01 by 2 can be taken as amount of copper sulfate, right? Then mass of copper sulfate required is given as 3 into 0.01 is nothing but 0.03, and it is divided with the 2, and it can be multiplied with its molecular weight of copper sulfate. So within the problem itself, they mentioned all the atomic weights. Take the sum of all the atomic weights, you will get the molecular weight of copper sulfate. It will be 159. 0.03 over 2 multiplied with 159. So that the correct answer will be 2.38 grams. Okay. So for this calculation, the essential thing will be how the reaction is proceeded. Phosphorus can be treated with sodium hydroxide under excess quantity. Phosphine formation and sodium phosphate formation is possible. This will be the salt form, right? Phosphoric acid basicity is 3, in that one of the hydrogen got replaced with the sodium, so that sodium phosphate will be formed. And whatever phosphine generated can be reacted, consumed with the copper sulfate, so that copper phosphide will be formed, and here another compound is sulfuric acid, right? So from this data we can go with the calculation. It is the number of moles mass calculation conversion factor we can put over here. And finally, we will get the 2.38 grams of copper sulfate required in order to absorb the phosphine whatever formed in this reaction number 1. So here the weight required for this will be 2.38 grams. So this is the way to solve problem number 3. Let's go with the problem number 4. The electrochemical extraction of aluminium from the bauxite ore involves aluminium as a metal, lighter weight metal, and mostly applied in the aircraft manufacturing. So aluminium metal can be extracted from the ore called bauxite. It is the oxide ore of aluminium, and moreover, bauxite is abundantly available mineral when you observe all across the world, right? The reaction of Al2O3 with coke at the temperature is less than 2500 degrees centigrade. So these are the options provided. From this we have to choose the what are the correct options in order to synthesize the aluminium from the bauxite ore by the process called electrochemical extraction, right? Electrochemical extraction most probably applied for one is aluminium, another is for fluorine. So let's see how it will be applied. Reaction of aluminium with coke at the temperature less than 2500. Neutralization of aluminate solution by passing carbon dioxide gas. Carbon dioxide precipitates hydrated alumina. Then the dissolution of alumina is at aqueous sodium hydroxide. The electrolysis of alumina mixed with the sodium, this is called cryolite, Na3AlF6 to give aluminium and carbon dioxide. Okay. These are the options provided. From this, the correct answers will be the neutralization of aluminate solution by passing carbon dioxide gas to precipitate hydrated alumina. Okay, so by this way, we will neutralize the solution. The dissolution of aluminium oxide, alumina, in hot aqueous sodium hydroxide, being aluminium oxide is amphoteric, it is readily soluble in sodium hydroxide so that it will be taken in the dissolution condition. And another electrolysis of Al2O3 mixed with Na3AlF6 to give aluminium and carbon dioxide. These three, B, C, D are the right answers for this electrochemical extraction. Let's see how can we achieve this. Okay. So, reduction of Al2O3 with the coke, temperature less than 2500 is not carried out due to the formation of carbides. Whenever aluminium oxide treated with coke, so here aluminium oxide will be converted into aluminium carbides so that the formation of product is not possible. Reduction process is not achieved, so A is not correct. B is correct. Neutralization of aluminate solution done by carbon dioxide, precipitate hydrated alumina. This is the correct option. Reaction of powdered one is carried out with concentrated sodium hydroxide. Temperature is 473 to 523 Kelvin and pressure will be 35 to 36 bar pressure. Electrolysis of Al2O3 is done mixed with Na3AlF6 to produce aluminium and carbon dioxide. It is also the correct answer. Let's see. Here is the entire process of electrolysis where you can find the graphite anode and the graphite cathode. So when these two electrodes are inserted, aluminium ore was taken and mixed with the cryolite. Right? Cryolite is also mixed over there. Molten aluminium is collected from this outlet and the steel case. The entire device was kept in the steel case. This is the process of electrolysis of bauxite ore and get rid of aluminium metal is possible. All right. Aluminium is the abundant metal on the earth. Everybody aware about this one. And it is mostly extracted by the process of electrical extraction, electrochemical extraction. Bauxite ore Al2O3, right? So bauxite is purified aluminium oxide. Alumina will be generated. So here from this alumina we can extract the aluminium. Here the process applied is electrolysis. Okay, and aluminium oxide must be melted so that electricity can be passed through this one. In order to melt this one, we need to heat more than 2000 degrees centigrade over its melting point. Very high melting point. At that melting point, we need to boil, we need to melt this aluminium, right? And instead, it is dissolved in the molten cryolite. Okay, cryolite will be taken. Cryolite, the purpose of cryolite will be to minimize, to lower the melting point value. Actual melting point is above 200 degrees centigrade. Every time maintaining this much temperature is very expensive and very difficult in the normal apparatus. That's the reason why here is the compound called molten cryolite, which quenches the melting point of the bauxite ore, right? The use of molten cryolite as a solvent reduce the energy cost involved in the aluminium, which used to minimize its melting point value, allowing the ions in the aluminium oxide move freely at low temperature so that aluminium and carbon dioxide will be generated. This cryolite used to generate aluminium metal and carbon dioxide, right? So whenever aluminium ion, that means alumina, bauxite ore containing alumina is treated by electrolysis, this used to accept the electrons by the process called reduction. And whatever oxygen is accompanied by with aluminium in this Al2O3, they able to release the electrons by the process of oxidation. This is the way we can mention redox reaction carried in the electrochemical process of aluminium extraction from bauxite ore. This is the way we can answer all the steps, where in a point number 1, aluminium oxide with the coke, there is a formation of carbide, so that we can't reduce this. We can't use this method. And neutralization of aluminates done by passing carbon dioxide. This is correct one. Dissolution of alumina in a sodium hydroxide is required so that we can neutralize. Electrolysis of alumina mixed with Na3Al6 gives rise to aluminium metal and exhaling carbon dioxide. So B, C, D are the right answers. This is a question collected from metallurgy. So that aluminium from bauxite ore, right? Let's move on to the next question. That is question number 5. The major product Y and Z in the following reactions are. Here, series of reactions are carried on the single compound. It is having multiple functional groups on the benzene ring. It's a purely organic chemistry, and we can say it is the organic synthesis, right? So, and these are called reagents applied, so that sequential process will be carried in order to get the mixture of two products. One is Y and either is Z. Let's see, it is the compound of benzaldehyde, where meta position is having hydroxy, para position is having methyl. Okay, so here 3 hydroxy, 4 methyl, benzaldehyde is the name of the compound. Upon treating with bromine in the presence of iron, it is the kind of Friedel group reaction where hydroxy group will direct the bromine towards a para position, so that we will get a para bromo with respect to OH. So that will be the compound one. After that, concentrated potassium hydroxide if treated, concentrated potassium hydroxide if treated, what will it do? So this aldehyde will be converted into hydroxy compound. This used to convert the aldehyde into hydroxy compound. And upon hydrolysis, everybody know that aldehyde, whatever aldehyde we are getting upon hydrolysis, that gives rise to the carboxyl. Higher oxidation state will be generated around the central compound, that will be carboxylic acid, right? Then compound Y will be CH2OH, compound Z will be COOH, that is the oxidized product. One is a reduced product, another is a oxidized product. Reduced and oxidized products are generated in the presence of base. Reduced and oxidized products are generated in the presence of base on the carbonylic compound is the example of Kenny-Zero reaction. Here, in the step number 2, it will be participated in the Kenny-Zero reaction, where one is reduced. With respect to aldehyde, reduced form is CH2OH. With respect to aldehyde, oxidized form is COOH. Same compound will be reduced and oxidized as well. that is carbonyl compound in the presence of B's, the process is called Cannizzaro. So that we will get mixture of Y and Z over here, and this bromo is directed towards para position. The right answer for this will be one is CH2OH and second is COOH. The correct option is mentioned over here. Let's go with the last question of the session. A solid has the structure in which tungsten atoms are located at the corners of the cubic lattice. Oxygen atoms are the edge centers of the edge centers, and sodium atom at the body center. The formula of the compound is, the right answer will be NaWO3. NaWO3 is the right answer. Let's pick out how it will be achieved. Okay. So here in the solid, W atoms are located in the corners of the cubic lattice. Corners of cubic lattice, you can notice the blue color lobes which are indicated with the tungsten. And oxygen atoms edge center. If you see the red color lobes, each edge center are given with this red color lobes which are belongs to oxygen. And sodium at the body center. At the body center, sodium atom will be there. This will be the crystal lattice of perovskite. Perovskite structure will be provided, and let's see how the atomic distribution is possible, right? So first of all, let's go with the sodium atoms. Sodium atoms are located in each corner of this cube. How many? 1 2 3 4 5 6 7 8 atoms are there, and each atom contribute 1 by 8. How many are there? 8 are there. So 1 by 8 into 8, it will become 1 only. Each corner of this cube contributed with the sodium atom, so that 1 by 8 can be multiplied with 8, so that answer of number of atoms of sodium are only 1 will be there. Each corner contributes 1 by 8 only. So in that way we can find 8, so that answer is 1. Let's move on to edge phase center. Edge phase center, if you observe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 oxygens are found. And its contribution is 1 by 4. Quarter contribution will be there. Okay. So edge phase center contribution is 1 by 4. In that manner, we have 12 oxygen atoms. 1 by 4 into 12 oxygens, that will give 3. So that the entire solid of sodium tungsten oxide will be given with the 3 oxygen atoms. Tungsten atoms are 1, oxygen atoms are 3. By this we found 3 oxygens. Let's go with the contribution of sodium. And the sodium atom is located at the center of the body center cubic. Okay, whatever atom located at the center will give the contribution of 1 only, right? So that hence the number of sodium atoms are 1 in the crystal. 1 sodium, 1 tungsten, 3 oxygens. Just now we got the entire calculation of each and every atom. Okay, all corners contributes 1 by 8. Phase edge center will contribute 1 by 4. Total center of the body centered cubic contribute 1. So that NeWO3 is the correct answer. It can be denoted as sodium tungsten bronze. This is called sodium tungsten bronze. So this is solid phase chemistry, physical chemistry quantities, and it is reduced as a NaWO3 is the correct answer. By this, we completed the entire session of this entrance examination or competitive examination chemistry. Hope this session will be very much helpful for you. I'm requesting you to like this content, comment over here, and share to the aspirants whoever preparing for. Subscribe the channel, and thank you very much for your patient listening. Thank you one and all.